Right, got C4 paper, the old content, June 2017, question 8, bit of integration, parametric integration, actually. It turns out there's some parts here as well, a bit of all sorts, really. Right, so figure 4. So there's this sketch with these parametric equations, and it gives you this point P. It doesn't give you the X value, it just gives you the Y value. And we're going to find out what the K is. Just here at Py is equal to 8, so that means that sec cubed theta is equal to 8. So the cos cubed theta is 1/8. So the cos theta is a half, giving you the theta, because it's in between 0 and pi/2, is pi/3. We want the x value really, because that's the k. So we need to stick pi/3 into here. So it's 3 times pi/3 times sine pi/3. Now you'll need to just put sine pi/3 in your calculator and then multiply it by this. These 3's will cancel. So it's pi times this. If you put the whole lot in your calculator, it'll give you a decimal. It wants the exact value. So there we go, that's part A. So the area can be expressed in that form. We're going to use y dx over d theta times d theta. The y is just sec cubed. Dx over d theta, we use the product rule on this one, so it'll be 3 times sine theta. So differentiate the 3 theta, multiply by sine theta, and then do it the other way around. Differentiate the cos theta, differentiate the sine theta, multiply by 3 theta. 3 theta cos theta. You got most of the marks there then, but there's a mark for getting the limits. We need to change the x limits into pi/3 and 0. The theta limits just here, the x value 0 and the theta value 0. And then if we multiply it out, if we do sec cubed times cos, sec times cos is just 1. So it'll be 3 theta times sec squared when you sort of cancel out a cos and a sec. And then also you'll have sec cubed times sine. So pinch one of the secs, make it into 1/cos, and 1/cos times sine. If you tan theta, so you get tan theta sec squared. And they've taken the 3 outside as a factor, make it look like that. And that's part B. Then for the last part, we've got to integrate this between pi/3 and 0. In the mark scheme, they put the 3 inside the bracket, so I'm going to go with that as well. So we're going to integrate theta times sec squared. We're going to do this by parts because I've got 2 things multiplied together. Here's the parts formula. The u is going to be the theta. And also, if I integrate sec squared, I get tan theta. Tan differentiated sec squared integrated is tan. So the sec squared, which is the dv over d theta, becomes tan theta when I integrate it. So the uv, well, the u is theta, and the v is just tan theta. And then I'm going to do minus the v times the u differentiated. The v was tan theta, and the u differentiated just 1, so we're going to integrate tan theta. That's in the formula book as well. Tan theta integrated is ln sec. So it's theta tan theta minus ln sec. I can put that into my big square brackets now. Incidentally, sec is 1/cos, so I can write it as cos theta to the -1, and then I can put the -1 in front. So it would be ln cos, but you don't need to do that. And then I've got to integrate tan theta sec squared. So what do I differentiate to get tan theta sec squared theta? Well, if I differentiate sec theta, I'm going to get sec theta tan theta. So if I differentiate sec squared, I'll stick the 2 in front, sec theta to the power of 1 less, which is just 1, multiplied by sec differentiated, which is sec theta tan theta, and that gives me 2 sec squared tan, which is what I want, just with the multiply by 2. If I differentiate tan theta, I get sec squared theta. So if I differentiate tan squared, I'll get 2 tan theta to the power of 1 1 multiplied by sec squared theta, which also gives me 2 sec squared theta tan theta. So as far as my integral goes, if I want to integrate tan theta sec squared, it's going to be either sec squared or tan squared. I need to multiply by a factor of 3/2 there. I need the 3 inside the bracket. I also need that half because I don't want 2 sec squared tan theta. And then I'll stick the limits in, sticking pi over 3 in, 3, pi over 3, tan pi over 3 is at √3, and then sec pi over 3 is just 2, because it's one of a cos, and cos pi over 3 is a half. And then tan theta, like I say, is √3, so tan squared is just 3. You put 0 in, you just get 0 all over the place. Tan theta is 0, theta is 0. Sec theta is 1, so ln of 1 is 0. And then the final answer looks like that.